Yeah, hello and everyone. Very welcome to this session that we're organizing together with Hugging Face. It will be about machine learning democratization. My name is Bram van Rooij. I'm part of the host institution. So we're the language and translation technology team at Ghent University. We're a research group working on a lot of different topics in natural language processing, going from terminology to emotion detection to sentiment analysis to chat to translation to readability to a lot of different topics. So if you're interested in any of that, then you can visit us on Twitter or our website. So our Twitter is at lt3ugent and our website is lt3.ugent.be, I think. But with that out of the way, why you're all, of course, here is our webinar, and we have the pleasure to welcome Nima Boscarino, who's a developer advocate at Hugging Face, and he's joining us all the way from Vancouver. So it's quite early over there. So very happy to have him here. He's going to teach us a bit about what we can do with our machine learning models. So Nima, go ahead.
Hello, everyone. Bram, can you just confirm that I'm unmuted and my screen's shared?
Yes, everything's perfect. Go ahead.
Awesome. Hi, everyone. It's very nice to get to join you all. I'm Nima, as Bram mentioned. I'm over in Vancouver, Canada. And yeah, I've been with Hugging Face for a little while, a few months. I work on the dev advocacy team, so this is kind of our bread and butter, advocating for everything that Hugging Face is sort of all about. I'll give you a really kind of brief overview of what we're going to look at today, and then I also wanted to say that if you do have any questions, the way that we're going to run this is I have like kind of a bunch of slides and a couple demos that we're going to go through, but feel free to either throw messages directly into the chat. I'm going to do my very best to keep an eye on the chat, but Bram, if you could let me know if I miss any messages, feel free to just interrupt me.
Yeah, sure.
But yeah, so at any point, feel free to throw questions in there, and I'll also pause at certain points. But yeah, so Nima Boscarino, feel free to follow me on Twitter, where I'll share more stuff about Hugging Face. Let's get started. So what we're going to be looking at today is a tour through the Hugging Face Hub. The Hugging Face Hub is sort of our central location where you're going to find all of Hugging Face's products and offerings, and it's where the democratization of the Hugging Face platform is really going to happen. And the two kind of main things that we'll start off by looking at in this like first half is Hugging Face's hub for models, and also Hugging Face's hub for data sets. And we're also going to look at how those two things are kind of interconnected. So we'll get started with a bit of an example. We're going to take a sort of toy example for a machine learning problem here. Maybe we work at a company, or maybe we're just particularly interested in ourselves in making a model that is able to take like a long kind of news article and summarize it, right? Maybe give us a short, like a tweet length or a paragraph length or something like that. We're building a news summarizer. And this is a really classic problem in machine learning. It's called text summarization. Very common task, lots of research done in it. And we should be able to find a model to do this. And again, the basic idea is we take a large article, we pass it through a model, and we want to get a short piece of text out. If we wanted to try to solve this problem or kind of embark on finding a good solution for this and training a good model for it, one of the first things that we would need to do is collect a data set. Machine learning is fundamentally kind of data driven. So that first step is just finding the data. Maybe we work somewhere where that data is already available. Maybe you work at a news organization and the news articles are already in your database. Or maybe you don't have access to that. And so you have to get crafty and you might scrape a data set together. You still will need to go through cleaning your data and preparing it so that it's ready to be passed through a model, maybe fixing any kind of weird issues. missing words, unknown tokens, whatever, things like that. That's something you're gonna have to do with the data. And let's say you have all that data, you've cleaned it, all the articles are beautiful, you fixed any typos or all that stuff. You still have to train a model. And in machine learning, this is often, it is an iterative process. It's gonna be made up of training a model. Maybe once you've chosen one, you're gonna train it, you're gonna score the score the model on like an evaluation kind of test set. Maybe you've got a bunch of different test sets that you're trying to aim for certain scores on. And then you may or may not be happy with the results. And so you might have to tweak some things, some hyperparameters. Maybe you adjust the learning rate or some other things. And you train again. And then you evaluate again, and then you train again. You evaluate again, and you train again with hyperparameter tweaking in the middle. Eventually, you come up with a model that you're happy with. Maybe there's certain benchmarks that you're trying to hit, and you've managed to hit those. Now the question is what you do with that model. Sometimes people might just upload it to a Google Drive or a OneDrive or something like that. Sometimes people just email model files to their colleagues. But in one way or another, you end up with an artifact that you need to put somewhere. So taking all of that in account, looking at sort of the holistic experience of developing in machine learning, you start asking yourself whether there's an easier way. Maybe you start looking at how software works already, right? The software engineering world has tools like GitHub, and has CI/CD tools, and has easy deployment tools. And maybe we start thinking about how to integrate all that stuff together to make the machine learning process a little easier, even across domains. So at Hugging Face, what we've done is we've tried to leverage the existing ML ecosystem, and we've tried to build on top of it, to build sort of like a one-stop shop, a suite of solutions that makes developing machine learning models a bit easier. We're not aiming to reinvent the wheel. We're taking tools that are tried and tested in the software engineering world. And we're also aiming for a collaborate first culture, right? You're going to see that makes the core of how our tools work. The way that we take it is that machine learning is already built in a collaborative way, right? There's discussions, there's sharing of data, there's multiple people working on different experiments. Collaboration is at the core of machine learning research and development. So we've taken that and folded it into our libraries. And the last part of this is open source. As you're going to see, the sort of ethos behind Hugging Face is that everything should be open source first. Pretty much everything I'm showing you today, you can go on GitHub and you can take a look at the code if you really want to and contribute. In fact, a lot of our stuff is driven by the community. So again, we're looking at taking the machine learning development process and kind of putting it all into one package to make things easier without reinventing the wheel. So that brings us to the Hugging Face Hub. Everything I'm going to show you today is sort of going to like spring out of here or in some way connect to this. Before we dive into the features and all of that and the stuff that we can do with it, I'm going to point out a couple more things that are sort of goals for what we sort of designed into this. And there's things that are maybe worth keeping in mind when you're thinking about why certain things work the way they do. Or if you come up with things to sort of match this structure that you think we should include, you're always free to like message us and we can talk about adding that kind of feature in. But at a very basic level, what we're trying to do is if we're making machine learning accessible, we want to make it accessible through open source libraries for engineering. And so we're going to take a look at libraries that particularly like are used in the ML process. And the other part of it is open science. So we believe in sharing the science that we do and sharing the research that we do. And a big part of that is going to be through sharing pre-trained weights for models so that other people can use them for their applications. So the particular kinds of problems that we're aiming to solve with machine learning at Hugging Face, sort of like laid out here, but you'll notice that there's one that's just like a big question mark. It's domain X. So Hugging Face started off as an NLP focused company. If you're familiar with sort of like our roots, we come out of, or we sort of sprang into being from the Transformers library, which is like a super popular library. It's up there on GitHub. It's a Python library that you can install, which gives people access to the sort of base structure of a bunch of very popular Transformers-based models. And those models are specifically in the natural language processing domain. We're working with text. Since we've worked on that, and since we've started building out this hub and the suite of tools around it, we've found that many machine learning problems, even though they might be in different domains, have similar workflows. And so the tools that we build work for those as well. The ones that we're specifically integrated with right now include speech, vision, biochem. You can see time series. Reinforcement learning is really cool. There's a whole course on that being released right now, sort of chapter by chapter, which is great. But we're always open and looking to add the next big domain in here as well. So let us know if there's something that isn't representative of what you work on or what you're interested in, so we can build integrations for it. Because at the end of the day, what we're looking to do, and again, core to what our mission is to democratize good machine learning. And we can only do that if we make sure that everyone's represented in here. This is just a screenshot of the main kind of like GitHub page for Transformer or for Hugging Face. We have a ton of repositories, all covering a whole series of stuff. But what you're going to see here is Transformers, just up at the top left, and that's our like most popular, well-known library. And that contains implementations of really popular Transformers-based models. And as you can see, like that is built in to the hub through some really cool integrations. But among the other libraries, they're also open source and available are things like datasets, which is a Python library that lets you integrate data sets directly into your machine learning, like training or evaluation workflows, both from the hub or other sources or local if you have a data set locally. And so we're going to play around with data sets a little bit. Tokenizers, this is a pretty cool library written in Rust, and it basically has everything that you need to turn strings of text into numbers that your machine learning models can ingest. And there's some other stuff in here that I do really encourage you to look into as well. But the ones that we're going to look at today are transformers and data sets. Okay, so we're going to, I'll right now hop onto the Hugging Face hub and we'll kind of poke around for a few minutes there. So let me do that. What I'm doing here is I'm going to hf.co or huggingface.com. If you're logged in, you're going to see something like this. If you're not logged in, then it's going to look a little bit more landing pagey. But once you're logged in, at the dashboard, you'll see like activities sort of related to the stuff that you've done. What I'm going to do is I'm going to go specifically into the models up here. And what I'll see here is a list of all of the models that we have available. There's 55,000 models on the hub. This thing is growing at an unprecedented rate. And these models are all categorized by language or libraries. So like if you're working with PyTorch or TensorFlow, or we're going to look at some of the other ones, they're categorized by tasks. And they're also categorized by languages if this is like a text model. So if you're looking for something in French or Spanish or German, then that's going to be in here. Now, filtering my task is going to just show me a bunch of other different models, and you can also see that you can sort them by various metrics. Here, see, I had a note for something I wanted to show you, but I guess what we can do is we can just pick a random one here. So I'm going to go ahead and pick BERT base uncased, and all of these models are equipped with what we call a model card. So a model card is going to contain all of the important information about a model. We've designed model cards after a paper. If you look up model card, you'll find Google Cloud model cards, or over here, model cards for model reporting. So we sort of designed our model cards after what this paper sort of outlines, which means we're including information about usage of the model, intended usage and limitations. So we're going to look at, what kind of bias might be encoded in that model, because that's important information for when you're looking to use someone else's model. And among other things, you're going to be stuff like the data that was used to train it, or what kind of pre-processing is required to make the model work. We'll pull this apart in just a minute. And then I also want to draw your attention to this series of tags up here. You're able to pack in tags for discoverability and just for filtering and things like that. So we've got a whole bunch of models. We've got over 50,000 public models right now. There's over 20 tasks. And what tasks are these things here over on the left-hand side. So image classification, image segmentation, or if I expand this right now, I'll see that I can break it down sort of by domain. So computer vision, audio, multimodal, things like that. And so I might go I want to see a sentence similarity model. And we're going to see that the Sentence Transformers organization here has uploaded a heck of a lot of sentence similarity models. And then the other thing here is that there's over 30 libraries. So one of the things that we want to make sure that happens with the hub is that models that are up here aren't just limited to, say, using the Transformers library that we maintain. We also want to make sure that people who use other machine learning frameworks and libraries are also able to use these models. And so we have integrations that let you work with, just PyTorch in general, or TensorFlow, Keras, in this case here, the Sentence Transformers library. And so if you have a particular need, you can always go into the filters and be like, okay, well, I want one of these right here. And then I have already mentioned here that there's over 180 languages. And one of the cool things about having a model hub and opening the upload of models to the community is that what we end up with is this abundance of representation, which is really great, because things like natural language processing are probably a little biased towards the English language. That's just a really big problem in research and also just in production. You want models that work for languages other than English. And that's becoming more and more possible because people are taking models and training them on their local languages. Community members are doing that and uploading their stuff to here. And I've found that just extremely cool. Okay, so I showed you a very brief example of a model card, but I'll go take another look at one real quick. This one here is the GPT-2 model card. And the GPT-2 model card, this model is a pretty famous model. If you're not aware of it, I would just recommend Googling GPT-2, or you can go to this model card and get a good description of, both what the model is, what it can be used for, and how to use it, right? We got code snippets and things like that. Something that's also useful is that people will put in, their evaluation results. How did this model score against some, test data sets that are standard in the research world. This here, I haven't mentioned yet. The models are all hosted on the hub as Git repositories. So if you're not familiar with Git, support GitHub. Git is what we call a version control system. Basically, you can think of it as a way to save your software projects, or really any project, save it with checkpoints so that you can build your project up over time. I would recommend looking into Git if you're not familiar with that already, but it opens up a lot of doors in collaboration. And so I think the more you dig around with this, the cooler you're going to find it. But if on any one of these models, you go into the files and versions, where you're going to find is all of the files that make up that model, right? And so in here, for example, we have like the PyTorch weights for that model, or the TensorFlow weights for that model, right? Because in this case here, this model supports both of them. You'll find that like these files are all like attached with like a message, right? And that's the like git commit. You know, the last time that somebody updated the model, that's what they wrote as a summary of what change they made to it. And you can see this model has been worked over a series of years. And something kind of cool that sort of makes our whole platform work is that we support large file storage. So these models tend to be really big. You know, in this case here, this one's 498 megabytes. It is not uncommon for you to find models that are much bigger than that. And in fact, you have space up to like terabytes to use on the hub. Probably don't want to make a file that's a terabyte big. You might want to shard it. But on the repo, like you can host as many things as you want. And we're doing that all free. We're definitely doing that at a loss, but the idea is to build the community. And what we've added recently as well is a community tab here. And so on any model, people are able to start discussions, but also make change requests, right? Pull requests. So if somebody wants to go ahead and edit something in the model card, or there's other kinds of repositories on the hub, which we'll look at, people might contribute things to that. You can imagine that maybe you have a model on here that's like a PyTorch model, and a community member might download that PyTorch model, convert it to something, like maybe convert it to a TensorFlow model or something, and then make a pull request to ask, hey, I did this work, like, would you want to include it? And then you have the opinion or the option to go in and see what changes they made and things like that. So that's version control, which makes a really big part of how the hub works. I'm going to show you one more thing, and I'll just double check that if there are any questions. But again, feel free to throw stuff into the chat, or honestly, I don't even mind if you hop in on the microphone. The last one that I want to show you quickly is these interactive widgets. So on any one of these models, we'll do this one here, the GPT-2 one. On any one of these models, there's going to be a hosted Inference API widget where Hugging Face is going to look at the configuration info for the model. And also, we parse a whole bunch of stuff just to see how we should serve it. But we end up embedding this widget onto the page where people can actually play with the model in real time. So if this is a model that does text generation, for example, then I can put in some text and it'll generate it for me. The people who uploaded this model were also kind enough to put a couple examples, right? And so those examples even get cached, which is kind of nice if the model is sort of like live already. And yeah, I can throw stuff in here. I am Nima, and today I will be, because again, at the core, so sometimes it's dependent on the model, but what comes up. Because at the end of the day, our idea is to democratize machine learning. And what that means is we want to lower the barrier for people to get to use models. This way, you don't have to download the model before you get to see what it does. And again, you can go to any one of these. So if I'm looking at, say, among the tasks, this image classification task, and I might pick this Google one. And what I'll find here is that there's an image classification widget, and I could pick this tiger picture, and I'll see the output here. I think this stuff is super, super, super cool. And it comes free in the sense that, like, the Hugging Face Hub will look at your model. It'll look at the information that you put into the model card. So So if I show you a model card, it's just a markdown file. So it's just going to be a bunch of text. But up here, you'll just get to say, oh, this is an image classification model. And for my widget, these are the 3 examples I want. And Hugging Face will do the rest. Like, we will set that up for you. Last thing here maybe is also that if you go to any model, you have the ability to embed TensorBoard like traces in there. And so on this particular one here, this example, they've opted to do that. They've included the training metrics. And so I can go in and I can even see a fully hosted TensorBoard. And so that might be something cool that you want to show off with your model. Cool. Does anyone have any quick questions? Or cool. Okay, so Anika says, does the Hugging Face Hub also support deploying your machine learning model on the web? You know it does, yeah, especially for someone starting out in AI. And yes, the transformers models are massive. That's a really great question. And the answer to that is yes. We're, if you can imagine basically this thing, the hosted Inference API, this widget is running right now. That's because when you upload a model, automatically the model becomes available to run, right? It will become available to run in what we call our Inference API. And so if I go under solutions here, I'll see that the Inference API is one of these. And what that means is that if you use a transformers model, it's already available. And in fact, you even get a like a widget, or sorry, not a widget, an endpoint that you get to use. Here I'm looking at the VIT-based patch model. If up at the top I go to deploy and accelerated inference, it'll by default give me a URL that I can access where the model is running online. Awesome. And it'll give you an API token that you can use for it as well. Robin says, any idea if someone is working on a Hugging Face version of GPT-3? That's a really good question. What we just did was there was a huge collaboration called the Big Science Workshop. Big Science Workshop was a collection of like 1,000 researchers. As Bram just pointed out, Big Science just trained a model called Bloom, which as of a couple days ago, reached 100%. And so here's an article from Nature. Here's an article over on Notion and all that. But you're able to even go to the Bloom book, which will take you through using the model. So definitely take a look at that. It's very cool. There's information about it on Twitter. Now, I wanted to point out yet again, you can use like any of the popular libraries for machine learning. You can either already use them on the Hugging Face Hub and with Hugging Face, or let us know and we'll integrate that stuff. The team works at a breakneck pace. Like we're adding stuff left, right, and center with input from the community. And so, for example, here is Keras. You can make your Keras model the way that you're used to if you're a developer who uses Keras. You've trained your model, and then at the end, you can just push to Hub, because from the Hugging Face Hub library, which you would just pip install, there's a push to Hub Keras. That'll push it up there, and we've built it so that it'll do things like generate that model card automatically for you. You can go in and customize the stuff in there, but automatically it'll add a bunch of information in there, and you're free to kind of like parameterize it. Now, we're gonna move past models kind of quickly here. I wanted to show you one more thing, which is data sets. The usual workflow for working with a model on Hugging Face is that you'll go to the model hub. We'll go to the model hub and we'll find a model that we really like. We'll be like, oh, I really like this VIT-based patch model. Or maybe I'm doing some sentence similarity stuff. And I go, oh, you know what? I really like this, all mini LM L6V2 model or whatever, right? Like this just matches what I'm trying to do. Maybe I've found that this particular model is trained on the data that I want, or that it meets certain metrics that I'm looking for. The next part of that is to load it locally and train it using a data set. If for some reason you can't train it locally, we do also have options over here on the solutions for training models without code on the Hugging Face hub. So I do recommend looking into that. But today we're going to sort of skip past that. So we want to load the model locally, train it with the data set. And then once we're done, we want to push it back up to the model hub. So the data sets makes a big part of how we're going to do that. You might be familiar with searching for your own data set online. There's lots of standard data sets on GitHub or just across the internet. What we've done is, in the same way that we've collected models onto the model hub, we've done the same thing for data sets. So if I go over to data sets, I'll find that there's over 6,000 of them right now, and we're working on adding more and more all the time. If you have a data set that isn't represented here, let me know, because that's part of my job, is to like find data sets and add them. And also, like, again, they're split by categories and tasks and languages and sizes, you know, if that's something you're looking for. Something we also really care about is licensing, right? Like, we want to make sure that both the models and the data sets are used according to the license that they're put up for. And so, you know, that information is always available for you to make a decision about. If you want to have a data set that maybe has gated access, like it's blocked, you know, you could either make a private data set, so only your organization or people that you're inviting have access to it. You know, they'll have to use a token, or you can make data sets where people have to agree to share their contact info before they're able to download the data set. And in that case, like, if you're the maintainer or the owner of the data set, you even get the information about every single person who has accessed it. And so we found that really useful. But if I go to any of these data sets, I'll find that there's this data set card, similar to a model card. Data set cards have a pretty standard structure. You know, we try to show at the top a preview of the data in there, so that, like, you know, you might not be able to see everything if it's a huge data set, but you get an idea of what you're jumping into. You could even break it down by subset or by split. If you want a test split or a train split, you can take a look at that. And again, there's going to be information possibly about a discussion of bias if the authors have included that, or a social impact. And using these can be done through the dataset library, which we'll take a very quick look at in a second. Something I wanted to point at before I sort of leave this page, though, is I do encourage you, as you're exploring the Hugging Face hub, is to look for, or what I encourage you to do is to look for integration. I just love that word. I've used it a lot. But what you're going to find is things like a link to the GitHub page, or showing you the models that have been trained with this particular data set, right? Or the Hugging Face leaderboard for models scored against this data set. This is something that I find really cool, is that we're also integrated with Papers with Code. And so if you want to find other models that maybe you might not be on the hub, you can go to Papers with Code and see what the latest in the research world is on that. I think this stuff is super cool, and we're building more and more into it. Like, I know that there's archives integration that's also, if not already built, it's on the way. Now, quick stats. We're the largest hub of ready-to-use data sets available, right? If you want a data set, we likely have it, or it's going to be exceedingly easy to add. You could do it, or you can ask us. But the basic idea is that there will be a file that we call the data loader file, or the data loader script. And in here is going to be information about, you know, this is just some metadata information about the data sets, but there will also generally be basically a script that will download the model, or sorry, download the data from wherever it's currently hosted. So maybe for particular reasons, it has to be hosted on the dataset maintainer's servers. We can do that. Or maybe it's hosted on S3. Maybe we're hosting it on S3. Then we'll have that sorted out. But you can take the datasets library and create your own datasets. So I want to draw like a distinction here. We have data sets on the Hugging Face hub, right? So there's a section of the hub called data sets where these things are stored. And you interact with them either through the UI, right, if you want to explore them, or if you want to use them, then you're going to use the datasets Hugging Face library, right? And so this is going to be a library that you can pip install. And once you've pip installed it, then you'll be able to connect to models to be able to list, or to datasets to be able to list the datasets available, or load a dataset with like a single line, which is honestly kind of mind blowing. Any questions here? Cool. Last thing I'm going to point out here. Oh, awesome, Gunther. I'm going to get to your question there in just a second. Before I forget, we support huge data sets. So if you have data sets that don't fit into disk space, we can do that. We can stream a data set to you. And for most kinds of data sets, that's just built in. You pass a stream parameter, and then you'll be able to just iterate over massive, like terabyte data set, just chunk by chunk, even shuffling within a buffer is supported. And then the other part of it is also that like any data set, even if it fits on your disk, right, on your laptop, you might not be able to fit the entire data set into RAM, into memory. But with the datasets library, you can, because what we do is we use a thing called Apache Arrow underneath. And what Apache Arrow does is it allows us to use a memory mapping technique so that what we're holding in memory are just pointers to files, and you're able to iterate and work with these big data sets that might not fit into your RAM. So that has been just absolutely kind of like, it smashed sort of the ceiling on what you're able to do on your local laptop, you know, or on a collab or something like that. Cool. So Gunther asks, regarding auto train for the non-free tier, is it possible to get free credits for educational purposes? That's a really good question. I'm going to write that down and I'll get back to you. I'm also going to tell Bram so that Bram can share this info. I'm not aware of this, but free educational credits for auto train. Cool. So I will get back to you on that after the workshop. Okay, so we are at 40 minutes in. I have 20 minutes left to go, and what this part is going to be is it's going to start being a little bit more hands-on. So in a few minutes, I'm going to share a link in the chat, and you'll be able to open it up and mess around with the same thing that I'm working on. So we've looked at the hub. We looked at the hub side of things, where you, as a researcher, as a developer, as somebody who's just interested in machine learning, can go and look for models and for data sets. And as powerful as that is, doing machine learning is sort of lonely unless you can share things. Oh, okay, cool. I got a message from somebody about the same question that Gunther just asked. So demos are a big part of the machine learning environment. You want to be able to show things to people. You know, it's not fun if you build something really cool and no one gets to see it. And so machine learning demos need to be easy to build. We're going to look at the old way to build a machine learning demo, or maybe the way that you're building one right now, and we'll show you the cool new way that I think is going to boost your productivity. And in my case, it boosted my creativity because it opened up a bunch of different possibilities. And the specific tool that we're going to use for that is Gradio, connected with Hugging Face Spaces. Hugging Face Spaces is, I'm going to say, the last pillar of models, data sets, and Spaces is going to round off what the hub is able to do. So to motivate a little bit behind the idea for demos, you know, you might be wondering, why do I even need a machine learning demo? Like, I made a model, I published it, it's all good. Maybe you have a website and a video. Having an interactive demo allows you to present your work to a really wide audience, specifically a wide, diverse audience, right? There's definitely a barrier to being able to use machine learning models without having an interactive demo. If I'm somebody who's interested in your work, I might have to go to your GitHub and download your model and then download your checkpoints and install the requirements. And oh no, I don't have CUDA or whatever, like all this stuff. And that's going to leave out people who might have really valid input on the model you've developed. People who might be able to identify bugs and failure points and bias, and social impact maybe you didn't think about. People who might not have a traditional computer science background. That's one half of it. The other half of it is it increases the reproducibility of your research. Because other people are going to be able to spin up demos, maybe built or maybe showcasing a model that's been trained exactly the same way as yours, and they want to show that, hey, yes, on paper with the evaluation scores and all that, it's the same. But also, if you want to mess around with it qualitatively, here you go. So if we've made the case for demos, and maybe you've already built demos in your life, you might start thinking through the process that you've gone through when you've been building them. This is me. I go, oh, okay, so I put a bunch of work into making a machine learning model. Now I want to show it off with a cool web app. I want to make something that maybe is going to go viral on Reddit or Twitter, or everyone's just going to go absolutely nuts for it. Okay, so let's make a list of the things that I need to know. If I want to make a backend, I probably need to know Flask or some other backend framework, maybe Node.js or I don't know, Ruby on Rails, Go, something like that. Maybe I want to deal with stuff at scale, and so I want to be able to deploy stuff in like virtual, in like containers. So then I might need to know Docker, and who knows, maybe I need to know Kubernetes as well. Some JavaScript is probably going to be necessary for your front end. My background used to be in web development, so I would have to bust out, Svelte or React for this. And then CSS, the ever-present just nightmare. Just formatting and laying out your demo so that it looks pretty. Huge nightmare. I give up. The number of times that I've seen people build something, go halfway through making a demo and go like, you know what, it's good enough. Like, it's just good enough. Just uncountable. Now, the thing is, there's a metric or a guideline, a rule of thumb that gets thrown around in the dev advocacy world, which is that the amount of time that you spend building something, you want to spend twice the amount of time on sharing it and on making it, public. And so that's going to mean, like making things look pretty and building the content around it, and also just spending time on social media. Same thing for machine learning. If you're not able to make a nice demo, there's that whole chunk of space and real estate that you're not able to capitalize on. So here we're looking at some of the breakdown of what goes into that. I've said training a model, like TensorFlow, PyTorch, one of those things is probably what you're using, and that's in Python. So likely you're already familiar with Python. If you use R or something else like that as well, there actually are integrations that you can use for Hugging Face. Like I just learned about Hugging Face R library, but there's a library called. You know what? Maybe I'll look for it and I'll share it afterwards on Twitter. But somebody is putting together like an R library to use the Hugging Face hub and transformer stuff and all that. But then everything underneath this, right? Everything under the stack, Bash and things like that for containerizing and deploying your model. You might need SQL if you want to keep a database where you store all the incoming samples, because maybe you want to take a peek at what people have been kind of putting into the model to try it out. And then in the end, the interactive interface, like that's HTML, JavaScript, CSS. Nobody wants to learn that. It takes time. So we bring in Gradio. Gradio takes that whole 3 steps under there and replaces them with Python. And not just with Python, but like I'm going to go ahead and say, compared to the machine learning code that you're writing, the Python code that you're writing for Gradio is going to be exceedingly simple, because we've taken basically the common things that you need to do, taking inputs, making outputs, and we've wrapped them up nicely. here are some examples of Gradio interfaces. Now, these screenshots are from Gradio 2. I did not update them for Gradio 3, so I'm sorry about that. But what you're looking at here is like a model demo where you are able to upload an image and it'll stylize the image into like an anime style, or in this case here, it's like a Disney style. And so this is my colleague Omar, and his picture's been passed through with the Disney model. So if you Google Jojo Gan, you'll find this. Here's another demo, right? This one's a bit more interactive on the thing. We've got some examples that you can click on down here. There's a URL that gets passed through. And then what happens is that the Gradio app behind the scenes here is downloading that article and then summarizing the news for you. And then the last one here, which is also super cool, is this particular demo is using a Microsoft model for like voice similarity, like audio similarity. And so we've got samples of 2 different speakers. And when you run it through, it tells you, oh, you're like 95.2% similar. You know, maybe you want to use this to like authenticate when somebody's like logging into a device or something like that. Okay, so those are just some examples of the kinds of things that you can build. And I'll share a notebook in a second where we'll like quickly look at this stuff together. But at the very basic block, Gradio is built up with this thing called an interface, right? As of Gradio 3, which came out a couple of weeks ago, there's a second API, which is a bit more advanced, and it does give you a lot more flexibility in things like layout and making multi-step demos. So if you wanted to make something that goes from like a pipeline, like a user puts in an input, generates something, puts in another input, combines it to generate something new, you can do that with the new Gradio Blocks API, which I do recommend looking at, or just message me and I'll show you about it later. But the Gradio interface API, all you have to do is you pass it a function. In this case here, imagine there's a classify image function. And then you specify what are the inputs, what are the outputs. In this case here, it's an image input and a label output that shows you the probability or the confidence of the various labels for that output. And then when you launch the Gradio app, it'll create the interface for you. And you can iterate on it and mess around with the functions if you want, but that'll be all created for you. So let me think about what I want to show you here. Let's touch on this in just a minute, because I also wanted to describe the fact that these demos are not just stored or saved like locally. They're not just for you. These demos are going to be available to be used for anyone that you send a link to. So when we do this app launch, it's going to give you a link that you can share with anyone. And the last kind of like big thing that I wanted to show you before we actually write some code is that these demos, like if you're looking for somewhere to host them, that's going to be the Hugging Face Spaces hub. Right? So what we call a space is basically an ML app. There's some on here that maybe you've seen before or heard about. Some of these have gone kind of viral, but they're all going to be this kind of basic idea where you have an input and an output, unless they've built a really funky demo. So in this case here, I'm doing a dog breed prediction. It'll give me a chart out. Gradio supports a massive amount of inputs and outputs, and I do recommend taking a look at the docs. Generally, if you're thinking about it, they have it. They or they'll add it. It's the turnaround time on like requests for certain inputs and outputs has been like a week, and then they have it ready for you. The space that some of you may be familiar with already is this one right here, the DALL-E Mini space. So DALL-E Mini went pretty viral recently. I have a slide about it. But this is genuinely just somebody made a Gradio space, hosted it on the hub. We're hosting it. And then they shared it with the community to showcase the model that they had built. So this here is an example of some stuff that has gone sort of popular on social before. This is like the anime GAN, and so people would just like upload pictures of themselves and share them on Twitter. And these are people who wouldn't be working with machine learning models otherwise, right? Like often it's just people go like, oh, cool, like that's something I can use. And researchers have found this really useful for like stress testing their models and also just getting the word out about the stuff they're building. But again, the perfect example of something going absolutely viral as a Gradio demo is DALL-E Mini. It's been renamed to Crayon because I don't think OpenAI is super happy about the DALL-E Mini name. But if you've seen any of these weird, pictures on Twitter or on Reddit or on Facebook or whatever lately, like this is extremely muscular George Costanza. That's from DALL-E Mini. That's from Hugging Face. I generated this one yesterday. It's Gordon Ramsay yelling at Elmo while he cooks in the kitchen. And this is just unprecedented, right? Like the ability to make machine learning so accessible that it hits like a critical mass of virality, right? And people are just going absolutely nuts for it. Like artists are able to start using machine learning models like DALL-E 2 or similar things like that to make art now, right? And interact, even though maybe they're not training their own models. Or training your own models becomes easier and easier and easier so that you don't even need to be able to code. That's where like the auto train comes in. And so you are genuinely just like a few lines of code away from making your own like viral sensation model. And I encourage you to try it out. I mean, if you have a model that you worked really hard on, why not wrap a Gradio interface around it and kind of like lower the barrier for usage? The return on investment is, again, just kind of unprecedented. So what we'll do here to round this off is I'm going to copy this link and I'm going to share this with you in the chat. You can open this up at your leisure or right now, feel free to run it even while I'm running this as well and messing around. And we'll take the last 10 minutes to actually like mess around with Gradio a little bit ourselves. We won't get to everything. This is not a super long notebook, but there's a couple more steps at the bottom. But I do encourage you to try it out later. So here, I'm skipping past this information that I've already shared, but it's basically just an overview of demos and whatever information about like how these are gonna be like hosted on the Hugging Face hub and all that. And I'm gonna skip right to like installing Gradio. So I'm just going pip install Gradio, and this will take a second. It's generally pretty quick. You can install various versions too if for some reason there's like, say today I noticed that there's a bug in something I was trying to do, so I was installing like one of the later checkpoints or whatever. But while I'm waiting for this, does anyone have any questions you want to type out or hop onto the mic for? I'm still here in case you do have questions. But the install is finished. And I'm looking here at sort of a first example of a Gradio interface. No machine learning going on here. You don't need to have an ML model to use Gradio. If for some reason there's something else you want to do, Gradio is inputs and outputs, and blocks of UI that you can put together. And so definitely feel free to go kind of wild on it. In this case here, we have a function that takes in an image and it applies like a sepia style filter on it. We don't need to look at the code itself, but the important part here is the second line, which is this import Gradio and then gr interface, right? GR interface, you pass it the function, you tell it which inputs and outputs you want, and you can find these particular ones on the Gradio docs, and then you tell it to launch. And what it's going to give me is it's going to give me like a fully built interface. This works in notebooks. Like I'm on Google Colab here, but if you're on a Jupyter notebook, it'll work in there as well. And this has been absolutely like just super powerful for me to be able to like work on stuff, reload the demo, like work on stuff, reload the demo. Like iterative works really well on this. And in this case here, like it gives me the input for an image. So I'm going to drag in an image for my cat. This is Jojo, my kitty cat. And I will submit, and it applies a sepia filter. And that's it. That's like all I need to do is really just write my code, which you might already have done, right? You just import your model or whatever, right? And you apply the model. And all of the UI is sort of handled for you. Here is a bit, more of an involved example. In this case here, I have a function that takes in a particular note, like A, B, C, whatever, any of the on the Western scale, an octave and a number of seconds that I want the note to play for. And I've got just some NumPy code here that'll generate just the wave for like the sine wave for that note. We don't need to worry too much about the code here, but what's interesting is that, again, our Gradio interface goes, here's the function, and here are my inputs. In this case, there's multiple, so it's like a drop down with some selections and a slider, from between 4 and 6 with a step size of 1, and then a number, right? And again, you can look at the Gradio docs to pick which of the inputs and how to use them. Notice also the syntax is slightly different. Here I just said image, right? And it'll just use the default setup for images. I could also go gr.image, right? And parameterize it, because every one of these inputs is going to let me customize it a bit. But in this case here, now I have this demo that lets me pick a note. I might go D, and I might go the 5th octave, and I want it to play for 2 seconds. And you're not gonna be able to hear it right now because I'm wearing headphones, but if I go submit, it'll generate the audio file for me. And it just played a 2-second D note in the 5th octave. Pretty cool. So audio is supported, multiple inputs are supported, and that multiple outputs are going to be supported as well. I wanted to point out just how these are hooked up. GR dropdown, slider, and number, notice that they're in an array or a list here. And so it's going to be positional. The first input is going to correspond to the first parameter for your function. The second one is going to be the second parameter, and the third one is going to be the third, onwards. And so that way you get to make kind of nice, legible code. And I mean, when I started at Hugging Face, I didn't know very much about Gradio, but this definitely tanked my productivity for a little while because I had work to do and I just kept making like weird little Gradio demos and messing around with the inputs. Because as a web developer, this blew my mind. Note also that all the Gradio code is open source. So if you wanted to go add a new component or see how they're built, by all means, you can check that out. We're going to do 2 more minutes here. I wanted to show you these last 2 things. This one is that if you have a model that you like on the hub, you can load it up and make a Gradio interface without even writing code, right? Like you don't need to do stuff with it. In this case here, it's looking at the fast speech 2 LJ speech, which if I go on Hugging Face is going to be a text to speech model. Again, I can use it over here on the Inference Api with the widget. But what I noticed this morning is there's a slight bug that's going to make this a little bit wacky to run in the notebook. The Gradio team is pushing a fix for it later today, but or at least later this week. But if we go take any of the other models, so I'm going to pick like image classification model here with the VIT base patch model. If I pick that and I go to my Gradio interface, I can tell it load Hugging Face, and then I just paste in the ID for that model. And you better believe So what it's going to do is it's going to parse the model information up there and just straight up generate the Gradio interface for you, right? And so here I am, and I don't know, where's my picture of my kitty cat? Here I am, and I get to submit, and it's going to run the model, and it's going to do the classification. I didn't have to write any code. Productivity just through the roof. If for some reason you wanted to add examples to your model, right? For some reason you wanted to add like just little examples to make it even easier for people to use it, you get to throw in an examples parameter with some inputs. And now people just get to click on it. They don't even have to type. Easy peasy. Raul has a question. If I load a model from Hugging Face that's very big, where does it run? For example, a transformers model that needs GPUs. That's a really good question. So if you have a model that for some reason doesn't run on Colab, right, or doesn't run locally, there's no need for you to have to download the model. So let me explain this two ways. One part is that like often if you go look at the way that people build Gradio apps with Hugging Face models, is that they'll like import the there's the Hugging Face hub like Python library, and then in here they'll go like, oh, I'm bad at typing, but model, there'll be like a load whatever, and you pass in the URL, and by default this is going to download it and run it wherever this is happening. Colab's going to have enough space, and so is like Hugging Face Spaces. Like we give you a ton of space and RAM to run this stuff. If you need GPUs, you can just ask us, and we'll figure out like a plan to give you a GPU. But you can also make web requests in here, right? You can make like an HTTP request in your function, right? Like I could go in here and say, oh, well, I got the inputs, and I go like requests dot whatever. And so you might have the model maybe hosted on your own server, or like in this case here with if I go any of these models, if I go to like burp base uncased and I get this deploy, I could just make a call to the Inference API where the model's already running, and it'll do this work for me, right? Like if I was to take this thing and copy it, let me just go to my sandbox, and I'll make this really big. And oops, oh, did I? Oh, okay, I copied the thingies. Here we go. Let me try that again. Ugh. So Python and okay, dang, I messed it up because I'm copying something wrong here. But basically, you take this and it'll just run it. So I guess the answer to your question is, where does it run? Well, it runs wherever you want it to. You could run it directly in the space in the virtual machine that spins up for you when you deploy onto spaces, or you could use the deployment solutions that we have, or anything else. In fact, if you go look at the DALI mini space, Bram has a question which I'll address in a second. If you look at the DALI mini space, this is a bit of a different space. We had to do a custom solution just because of the scale that we were getting. But if you go into the HTML and the JavaScript and whatever, there's an HTTP request being made to somewhere where we are hosting the model. So yeah, I hope that answers your question, Raul. Bram's question is, the Inference API is a paid service, right? The answer is yes. So the Inference API is paid, but there's a free tier, right? So with a free tier, you get access to a CPU, or CPU inference, and you get 3,000 input characters per month. There's a dashboard where you can keep track of your usage, but if you have a particular usage in mind, just email us. We're really responsive. Like the customer success team is amazing. Like it says here, customer support, and they'll work with you to figure out what the appropriate way to do this is. But there's also like pay as you go for labs or a pro plan. This is how you can get access to GPUs. And so we're very flexible on that. I think, since I've taken you 5 minutes over time, what I wanted to encourage you to do after this, if you have the time, is explore how to get a model up, or sorry, a space up on Hugging Face, which means that you could take a Gradio app that you have made. Like I could copy any one of these, and I'd be able to go to new space, and it'll give me the opportunity to select a Gradio space, or there's some other options which are out of scope today. But if I make a Gradio space I'm going to delete this one in a second, but it'll give me a repository where I can git clone if that's what you want to use, or even directly inside of the repo, you can just create a new file, and you would like paste it in here. Once you've done that, Hugging Face Spaces will build your app, and it'll serve your thing. And so, for example, if I go look at one that I built just last night, Spaces, June 30th, Sepia, I uploaded that like Sepia demo. And so literally all there is in here that I added was this app.py file. And now I have for free, like this is for free now, it's for free forever. I have the thing running and I can just run it. Sometimes it takes a minute or two to load up if it hasn't, if the model hasn't been loaded recently. But that's it. It's just up there. And I encourage you to dig deeper into it if you find it interesting. Oh man, Brian, I'm so sorry. I've taken you 7 minutes over time. Do you think it's okay if I talk about classrooms real quickly?
For me, it's fine, I guess. And if people have to go, then people have to go. So then they'll leave. So yeah, sure, go ahead.
Awesome. So this last one here, I I didn't time that section, and so this is why I went a little over. We have organizations on Hugging Face to allow you to collect together users and the work that you're doing. And so you've noticed like many of the models up here, their names, either they don't have a name, which means we're managing it, or they have something like OpenAI, which means that the OpenAI organization, I can click on here, the OpenAI organization has a couple of team members and they've uploaded models, right? And then they get to collaborate on that, and they can choose to make this stuff public or private. So we have a whole number of like private stuff that people can't see. And among the kinds of organizations that we offer, like you'll notice this is a company organization, what we also offer is it's classrooms. So we created a classroom for today's demo. And so let me just go forward here. I have the link in here just so that like you can add yourself to it. Classroom it is. So this is today's classroom link. If you click on that, you can just join our class. But a classroom is going to allow teachers, in this case, to give their students like a dedicated workspace where people can upload their assignments. You know, maybe a teacher might upload data sets that you're going to be having your students evaluate against, so that your students are able to use those data sets like while they're working on their projects. Generally, any of the things that you can think of that can exist on the hub, we can put that in there. You know, maybe you have ideas for stuff that classrooms should have or that you want, such as one that I think would be really cool is like leaderboards. Or maybe that adds a little bit too much competition into an educational setting, but things like that are like automated kind of places where students can like evaluate their own work. That's stuff that, you know, might be down the line for them. Here's a summary though, is like the training is sort of you know, it's sort of integrated in there. Collaboration is built in because multiple people can work on the same model or the same space or the same data set or any of that. All of that is sort of integrated in there. And again, if you visit the link that I put in there, what it's going to open up for you is is this going to open up this particular class that we have for the language and translation technology team. I see that a bunch of people are already in it, and you will now have access to add stuff in here. And there's information in that notebook, in this one here, down at the bottom of the notebook. There's oops, it's not loading for me. Down at the bottom of the notebook, there's going to be information on how you can move your models into a classroom. And so this is how your students are going to do that. Bram says, this is relevant for Gunter's question, which was for educational credits. So I'm going to look into that, and that'll be no doubt. I really want to thank you for sharing this time with me, and for for your questions and for being engaged. I hope this was educational for you, and do feel free to reach out to any of us, like Bram, me, Violet, anybody at Hugging Face is always happy to talk about stuff. Yeah, Bram, I'll put it back into your court.
Yeah, Nima, thank you so much. I think it was very interesting, both for people who already were familiar with some stuff and some for whom it was completely new. So thanks a lot. So as you said, for questions, they can reach out, but what would be the best place? Maybe the forums? I'm not sure.
Yeah, absolutely. So we've got a couple places. This is going to be the Hugging Face forum. And so the forum is going to be useful for you for if you have like technical questions. People are going to be super responsive there. If you have questions specifically about product and like pricing and things like that, I would reach out to like customer support. And so I don't know if I have that on hand at the moment, but I can get that to y'all, the info on that.
Sure.
Brent, do you know what our email would be for that?
I don't know your email addresses. No, no.
Yeah.
Here
Give me 1 second and I'll pull it right up here. If you send it to like feedback at huggingface.co
maybe,
for
yeah.
like
on the support page, there's a request a quote, and then you get sent to a form. So maybe they can fill that out. No?
Perfect. Yeah, exactly the request a quote. All of this stuff is going to go to the whole team, and we'll
oh wow, okay.
Yeah, I'm pretty sure you could even just go help at huggingface.co or support at huggingface.co. We'll get it. We'll definitely get it. I troll Twitter as well, so if you
okay.
go on Twitter, then we'll get you there.
We can find you wherever we want.
Perfect. Yeah.
All right. Yeah, if maybe anyone else has a question, and now is the time, so you can put it in the chat or you can open up your mic. All right. If there are no more questions, thanks again so much, Nima. We'll stop the recording and put it on YouTube for the world to behold. And then, yeah, thanks again. Thank you so much. Then we can stop it here.
Perfect.
I bet that people are applauding behind their screens right now.
Oh, thank you, Pablo. Thank you, Arda. Yeah. And again, feel free to reach out on Twitter. I'm too active, so message me there at any time. Follow me. I'm trying to bump those numbers up. Yeah. Thank you very much, Flavie.
All right, that sounds good. All right, I'll leave the conversation then, and have a good morning, I guess, to you.
Yeah, have a good night.
Have a nice day. Yeah, enjoy your day. Thanks again, man. See ya.
Right. Bye-bye, everyone.